Have you ever wondered how something as grand as a dinosaur could leave behind something as small as a fossil? It's a journey with many twists and turns, and it all starts with a bit of luck. Imagine a dinosaur dying in a riverbed. Its massive body sinks into the soft mud. This is where the journey begins. The first hurdle is decay. Bacteria and scavengers get to work breaking down the soft tissues. But if the conditions are just right, the hard parts, the bones and teeth, can survive. This is more likely if the remains are quickly buried by sediment like sand or mud. This acts like a protective blanket, shielding the bones from further decay in the elements. Now buried, the real transformation begins. Over millions of years, layers of sediment pile up, pressing down on the bones. Water seeps through these layers, carrying minerals like calcium and silica. These minerals slowly replace the original bone, turning it into stone. What was once bone is now a rock replica, a fossil, ready to tell its ancient tale. Dinosaurs ruled the Earth for a staggering span of time, over 180 million years. To put that in perspective, humans have only been around for a few 100,000 years. This age of dinosaurs, spanning from the Triassic to the end of the Cretaceous period, was a time of dramatic change. During the Triassic, the continents were clumped together in a supercontinent called Pangaea. The climate was hot and dry, favoring reptiles like dinosaurs. As time marched on, Pangaea began to split apart, and the climate became more varied. Lush forests covered much of the land, providing homes for giant herbivores and the fearsome predators that hunted them. But the environment wasn't always so hospitable. Volcanic eruptions spewed ash and toxic gases into the atmosphere, and the climate fluctuated between extremes. These events shaped the evolution of dinosaurs, driving some to extinction and allowing others to thrive. Understanding these ancient environments is key to understanding why dinosaur fossils aren't found everywhere. The fossil record is like a giant jigsaw puzzle, with most of the pieces missing. Finding a dinosaur fossil is incredibly rare, and there are many reasons for this. First, not all environments are conducive to fossilization. Dinosaur bones left out in the open are quickly weathered and eroded away. Natural disasters also play a role. Volcanoes, earthquakes, and floods can bury fossils under tons of rock, making them inaccessible. Or they can destroy fossils altogether, leaving no trace behind. Imagine a powerful tsunami washing over a coastal plain, scattering and grinding up any dinosaur bones in its path. And then, there's us. Humans with our cities and farms have significantly altered the landscape, often destroying fossils in the process. Construction projects, mining operations, and even simple plowing can obliterate these irreplaceable pieces of the past. The fossil record is a fragile thing, vulnerable to the whims of both nature and humanity. Fossils are more than just bones. They're snapshots of ancient life, each type offering unique insights into the past. The most familiar are body fossils, the preserved remains of an organism's body. Bones, teeth, and shells are the most common, but even soft tissues like skin, feathers, and muscles can be preserved under the right conditions. Trace fossils tell us about an organism's behavior. Footprints reveal how a dinosaur moved, while nests and eggs offer clues about their reproductive habits. Coprolites, fossilized feces, might not be glamorous, but they tell us what dinosaurs ate. Then there are the truly exceptional fossils, those that preserve an organism in exquisite detail. Insects trapped in amber, their delicate wings perfectly preserved. Mammoths frozen in permafrost, their last meal still in their stomachs. These rare finds offer a glimpse into the past with unparalleled clarity. The thrill of the hunt adventures in dinosaur fossil discovery. Finding dinosaur fossils is an adventure that requires patience, skill, and a healthy dose of luck. Paleontologists, the scientists who study fossils, often spend years in the field, scouring remote and unforgiving landscapes. They use geological maps and satellite images to identify promising areas, places where sedimentary rocks from the Mesozoic era are exposed. Once a potential site is located, the real work begins. Paleontologists use a variety of tools to excavate fossils, from delicate brushes and dental picks to jackhammers and heavy machinery. Each fossil is carefully documented and removed from the rock, a process that can take months or even years. The thrill of discovery makes all the hard work worthwhile. Unearthing a new species of dinosaur, a creature never before seen by human eyes, is an experience like no other. Each new fossil adds a piece to the puzzle of the past, helping us to better understand these magnificent creatures and the world they inhabited. dust to dust, decay, and the race against time. When a dinosaur dies, the clock starts ticking. Decomposition, the natural process of decay, begins immediately. Microorganisms like bacteria and fungi feast on the soft tissues, breaking them down into simpler compounds. This process is aided by scavengers, animals that feed on carrion. The speed of decay depends on a variety of factors, including temperature, moisture, and oxygen levels. In hot, humid environments, decomposition is rapid. But in cold, dry environments or in environments with low oxygen levels, decay can be significantly slowed. This is why we find well-preserved dinosaur fossils in deserts and other arid regions. Certain parts of the dinosaur's body are more resistant to decay than others. Bones and teeth made of hard, mineralized tissues are more likely to survive. Soft tissues like muscles, skin, and internal organs are much more susceptible to decay. For fossilization to occur, the remains must be buried quickly before decomposition can destroy them. Sedimentation, the process of sediments like sand, mud, and volcanic ash accumulating over time, is crucial for fossilization. Think of it like this. Imagine a dinosaur bone lying on the ground. Over time, wind and rain would erode it away, but if that bone is buried quickly by sediment, it's protected from the elements and the ravages of time. Rivers, lakes, and oceans are prime locations for sedimentation. As rivers flow, they carry sediment downstream, depositing it in layers. Lakes act as natural sediment traps, collecting material from their surroundings. And the ocean floor is a vast repository of sediment, constantly accumulating over millions of years. The weight of the accumulating sediment compresses the layers below, squeezing out water and creating sedimentary rock. The dinosaur bone encased within this rock undergoes a remarkable transformation. Minerals from the surrounding water seep into the bone, replacing its original organic material with rock. The Earth's surface is not static. It's a dynamic, ever-changing landscape shaped by the movement of tectonic plates, the massive slabs of rock that make up the Earth's crust. These plates collide, separate, and slide past each other, creating mountains, volcanoes, and earthquakes. This constant movement has a profound impact on the fossil record. Tectonic uplift can raise ancient seafloors to towering heights, exposing fossils that were once buried deep beneath the ocean. The Himalayas, for example, are home to marine fossils, evidence that this towering mountain range was once submerged beneath the sea. Conversely, tectonic subduction can drag fossil-bearing rocks down into the Earth's mantle, where they are melted and recycled. This process destroys countless fossils, leaving gaps in the fossil record. The movement of tectonic plates is a constant reminder that the fossil record is incomplete, a fragmented archive of life's history. Erosion, the gradual wearing away of rock and soil by wind, water, and ice, is a double-edged sword for paleontologists. On the one hand, erosion is essential for exposing fossils. Without it, fossils would remain buried forever, locked away in the Earth's embrace. On the other hand, erosion can destroy fossils just as easily as it reveals them. Wind-blown sand can sandblast delicate fossils, wearing them away grain by grain. Rushing rivers can carry fossils downstream, scattering them far and wide, and glaciers like giant bulldozers can grind fossils to dust. The effects of erosion are particularly evident in areas with dramatic topography, like mountains and canyons. These areas, while often rich in fossils, are also subject to intense erosion, making the search for fossils a race against time. Not all environments are created equal when it comes to fossilization. The ideal environment for fossil preservation is one that allows for rapid burial and minimal disturbance. Aquatic environments like rivers, lakes, and oceans fit this bill perfectly. The constant deposition of sediment in these environments provides ample opportunities for burial. Deserts, despite their harsh conditions, can also be excellent for fossilization. The dry climate limits decay, and the lack of vegetation minimizes disturbance from roots and burrowing animals. That's why we find so many well-preserved dinosaur fossils in places like the Gobi Desert and the Badlands of South Dakota. Forests, on the other hand, are not ideal for fossilization. The acidic soils and abundance of decomposers rapidly break down organic material, and the dense vegetation makes it difficult for fossils to be buried quickly. That's why dinosaur fossils are relatively rare in forested environments. The type of environment where a dinosaur lived and died played a crucial role in determining whether its remains were preserved as fossils.